Alrighty, in this video we're going to be looking at expected number, which is part of our experimental probability unit, and in particular it's used for when you have a given probability but you want to predict or anticipate a certain outcome and make decisions based upon that outcome. So the formula is this. It looks complicated at first, but when you break it down it's not so bad. The expected number of some event, whatever it happens to be, is equal to the probability of that event happening once and multiply that by how many times it happens. So a very simple example would be if I was flipping a coin. And assuming the coin is a normal coin, it's 50-50 between heads and tails, a probability of 0.5 or a half for each one. So if I flip the coin, let's say 100 times, then I ask you what is the expected number of tails, you would probably just say 50. Just intuitively, you just know it's 50. But really the maths that you've done is you've gone the probability of it happening once is a half, and you've multiplied a half by how many times we did it, 100, and you got a half of 100 is 50. And you've done that all in your mind. However, sometimes we need to explicitly write it out so we can understand the topic, so we can understand the formula, and we're going to do that in this next example so we don't have to rely on intuition or guessing. Alrighty, now let's do an actual question. So in the question below it says a box contains an unknown number of coloured balls and a ball is drawn from the box and then replaced. The procedure is repeated 100 times and every single time the colour of the ball is noted, and 25 red balls were drawn out during the process. Part A says calculate the experimental probability of this happening. So our experimental probability, which I'm just going to denote as EXPR, of getting a red ball is how many times did it happen over how many times did we do the experiment in general. So we got 25 red balls out of a possible 100, which gives us an experimental probability of 1/4. If you divide both of these numbers by 4, you get divide them both by 25, you get 1 and 4. So a quarter of the time they were red. That's not to say that a quarter of the balls in this unknown box were red. It just so happens that in this experiment, we got 25 red ones, also known as relative frequency in this case. Now part B. It says, find the expected number of red balls drawn if the box contained 500 balls in total. So initially, with this part, we didn't even know how many balls were in the box. But given this new information, presuming that there are 500 balls in the box, how many should be red based on this first experiment? So I'm going to use this formula up here. So we get the expected number of reds is equal to the probability of getting a red, which is 1/4, multiplied by the number of times we did it. Now here's the thing. Initially, to get this experimental probability, we did it 100 times. However, for this case, the number of trials, in this question, it's asking us what if there are 500 balls? And that's what I'm going to put in here, the 500. So if we repeated it 500 times using the probability of 1/4, we should get 125 red balls. Now, there could be 300 red balls, there could be 100, they're all red, but actually they can't be all red. We only got 25, so we must have got some other colors, but let's say that there is not necessarily exactly 125 in the box. It just so happened with this experimental probability and the fact that we were drawing out of a box of 500, we would anticipate, or we would expect, there to be 125 red balls.